Now let's use induction to solve this problem. So we want to find what is the sum of the first n odd numbers. So if you do 1 plus 3 plus 5 plus 7 and so on, can we find some closed formula for that? Now, one of the issues with induction is that generally you have to have some guess of what the formula might be to then use it. And so that might be one of the weaknesses. Now, if you have a guess, it gives you a very powerful way to check whether that guess is correct or not, right? So for this problem here, let's first try to look for a pattern. So what is the sum of the first n odd numbers? Well, when n is equal to 1, then of course it's just 1. When n is equal to 2, you get 1 plus 3, which is 4. When n is equal to 3, you get 1 plus 3 plus 5, which is going to be 9. And let's say one more, when n is equal to 4, you get 1 plus 3 plus 5 plus 7, which will be equal to 16. And here one could already start to think, well, can I have a pattern here or have a guess at what this might be? Well, if you look at it enough, you might come up with the idea, well, maybe these are just the squares of the numbers. So this, for example, is just 1 squared, this is 2 squared, this is 3 squared, and this is 4 squared. Now, it doesn't mean we haven't proven that this is the pattern, so maybe it's not true. Also, checking just a finite amount of cases will never show that it's true for the infinite, at least potentially. Who knows what happens later on, and that's why we need something like induction or some other technique. But for now, if we do n equal to 5, we would expect then to get 5 squared, which is 25, and we can check. So 1 plus 3 plus 5 plus 7 plus 9. So it's the previous sum. So of course 1 plus 3 plus 5 plus 7 is 16, and then plus 9 is actually going to be 25. And so it does seem like this is a good candidate for a conjecture. So for now, we will have that as a conjecture. We're going to be like, oh, we think, so our conjecture, and maybe it's true, maybe it's not, our conjecture is going to be that the sum of the first, or let's write it like this, 2n minus 1 of the first n odd numbers will be n squared. Okay, let's try to prove that then by induction. Okay, so let's see if we can prove this by induction. So as usual, we start with the base step. So the base step. So in this case, we want to show that it's true for n equal to 1. Okay, so then the left-hand side here is just going to be 1, right? It's just the first odd number. And the right-hand side is going to be n squared, which is equal to 1. And okay, so it's true. So it checks. The base step is true. And so now we can do the inductive step. So what was the inductive step? So again, what was the idea of induction? The idea of induction was that you show that something is true for, say, the number 1. And then you show that if it's true for a number, it's true for the next number. And again, the intuition is that if it's true for a number and it's true for the next number, and it's true for number 1, then it should be true for the number 2. But now if it's true for number 2 and it's true for the next number, it must be true for number 3, and so on. So the inductive step, we assume true for n equal to k. Okay. And what does this mean? this means that we are assuming that this sum here up to 2k minus 1 is equal to k squared. And now we need to show then for n equal to k plus 1, we need to show that this formula here holds when you replace n by k plus 1. Okay, so let's do it then. So again, let's just write the left hand side. So we'll have 1 plus 3 plus 5 all the way to 2k minus 1, and then since we're going until k plus 1, to 2k plus 1 minus 1. Let's write it like this. Okay, so this is the left hand side here for n equal to k plus 1, and we want to essentially show that this is k plus 1 squared. And what we are able to use is the inductive hypothesis here. So in this way here, the inductive hypothesis already appears quite clearly. So 1 up to the sum of the odds up to 2k minus 1 is equal to k squared. So by the inductive hypothesis here, I can write this as k squared plus, and 2k plus 1, so this is going to be 2k plus 2 minus 1, so this will just be 2k plus 1. And notice that this is just k plus 1 squared. So if you do k plus 1 squared, you get k squared plus 2 times the first with the second, 2k, plus the second one squared, 1. And so this, the sum, so the left hand side here with k plus 1, which is this, is going to be equal to the right hand side here with k plus 1. And so we've shown what we want. Thus, the statement holds for k plus 1. And so what does this mean? Then by induction, the formula holds for all positive integers n.